Hi there, 8th graders. Lesson 26, transformations. Objective to understand congruency, transformation, reflection, rotations, translation, and the effect of the orientation of an object. Show transformation on a coordinate plane and describe the translation within an order pair of movements. Model the transformations, dilations, and contractions affect an object. Okay, power up. At this point, you can do your power up to get your mind thinking about math. I pause it now as I'm going to move on. Reflection is a transformation representing a flip of a figure. Rotation, which a plane figure turns around a fixed center point. Transformations are operations on a geometric figure that alter its position or form. Translation, all the points in the object are moved in this straight line in the same direction. Okay, right now you have a transformation that moves triangle ABC to a location A triple prime to B triple prime to C triple prime, which means it probably moved 3 times. Okay, there's a couple different ways you can do this. It depends on how your mind thinks. Obviously, it's probably going to take 3 operations. So the first thing that I might do is go flip it across my axis of symmetry here. So this would become C. And I forgot to freeze it. Alright, so this becomes C prime. Right here. C prime, A prime, and I should be able to. Okay. And we're going 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so we have a figure that now looks like this. So you have something that looks like that. That's probably my first translation. I did a flip across the y-axis. Okay, now on the next one, I'm going to rotate it. Probably based off this point right here. Okay, so this is also going to be C double prime. I'm going to rotate it counterclockwise 90 degrees, which means 1, 2, 3, 1, or that would put B up top. So 1, 2, 3, 4, 1, 2, 3, 4. A double prime. And B is going to be up 1, 2, 3. And then I'm going to do a translation, in which case I'm going to slide it here. I'm going to slide it here, and slide it right here. So, that would be your 3 operations to get it in the right spot. So, it's grand old time. Okay, so that would be that. I'm going to erase this before I unfreeze it. don't look like it paid off. Okay. Now, on this one, it says measure the lengths and widths of A, B, C, D above, and its dilated image reflection A prime, B prime, C prime, D prime. So, if I do measure this, I'm probably going to try inches and see what happens. Right now I'm getting about 6.5 here. Means that's probably 6.5. So this is about 3¼ inches. So this would be about 12¼ . And obviously, if I'm taking this out of the book, yours will be a little bit different. Because I measured it exact, it should be a scale factor. I'm not going to say this works because of the fact I pulled it off of yours. And I'm trying to measure it. Obviously, when you transfer stuff onto the computer, if you start messing with it, like by expanding your box, you are dilating your image. But it can also mess with it depending on if you pull from the corner or if you do not. Which I'm not too far off. My scale factors are not perfect considering I blew this up, but it isn't too bad. Obviously your scale factor should be the same in your dilation. What is the scale factor of it? Well, I'd probably go in the middle of those two and probably say it's about 0.52, or you could divide it the other way and then you get whole numbers, which is going to get you like 2. Which is probably the better way to do, because it'd be 1 to, or 2.52 inches right now, is what your scale factor is. The perimeter of the image is what multiple of it? Well, if each side is double the length, I almost want to go the other way, I think. Or multiply this and make it so it's like a whole number. So it'd be about 1 to, or 2 to 1, and that'd be small to big, or big to small. So it says, what would the factor be? Well, the first one, you're going to be 2 times as large on each side as the other one, so it's probably going to be times 2. What is the area going to be? Well, let's say you have 6 and 4, just to make it easier, I'm rounding. Okay, and you have 12 and So you end up getting, here you get 24. You're going to, you wouldn't quite do that though. Let's go 12 and 6. And you will get 48 times, which I feel is a touch off. Because it should be, that might be about right. Like I said, it's messing with me a little bit because I blew up the image. Yours should not look like that. Your scale factor is the same thing that I got at about 2, which makes the perimeter 2 times as big, which then should make your perimeter 4 times as big. And that's what's getting me right now, and I don't know if it's because of my measurements, but let's go with, this should have been double as big, so your scale factor means it should be double as big. This should have been 8, which then would be 7, no, it'd be 96, which then this would be times by 4 equals, so on C it'd be 4 times. Some reason when I stretched mine, it does not work out perfectly. Obviously I wanted to show you guys how to measure it based off mine. Mine is going to be a little off, so if you follow your measurements of yours out of the book, it should be a little bit more accurate. Guess that's why you have to go back to. Do your written practice. Like I said, at this point, you can bring it in, show me, and we can make sure every single one of those is correct, and then go from there. There is your